Hello all, welcome to the research project presentation by Kiran Kumar Pattur, a graduate student at University of Houston. The project title is Using Simulation Modeling for Look-Ahead Schedules in Construction Industry. This project uses Simio software with technical guidance from Mosem Tech. Project failure rate is high in construction industry compared to other industries. There are several reasons for this like communication, lack of expertise, and several. We have few tools like key performance indicator, end value management, project percent complete, etc. to detect the project failure before it occurs. But these tools are mostly used only at master schedule level. In construction industry, project failure rate can be predicted early if we can plan and keep track of look-ahead schedules, which are also called weekly or bi-weekly schedules. Keeping track of look-ahead schedules will help the project managers to detect slippage of schedule early in the project so as to take necessary actions immediately before it is too expensive to bring the schedule back to track. By definition, simulation is imitation of operations of a real-world process over time. Application of simulations have proved to be yielding successful results in several industries including manufacturing, healthcare, mining, and even in construction industry. In construction industry, most of the research carried so far by applying simulation is limited to heavy civil construction and mostly limited to one activity in the project. The experiments have already proved that using simulation will give more accurate predictions. In this project, we have modeled few interior construction activities to check if simulation can be used for predicting schedules with confidence. We have used Simio software, which is developed for manufacturing industry but spread into several industries like healthcare, supply chain, mining, etc. because of the multiple modeling paradigm used, including process orientation and event orientation applications. Let's take a quick look into methodology or process used for this research. After analyzing the previous literature review on simulations, we have developed an example problem which is complicated enough to show that parallel tasks can be simulated at the same time, not too complex to understand and model in this software for the beginners level. Then we collected work performance estimation data from professionals across industry and modeled the activities and verified the model, making sure that model runs logically correct. We have input the data into the model and verified relevance of outputs. We then analyzed the results and concluded if simulations can be used in look-ahead schedule for predicting the schedule at a good confidence level. I'll quickly introduce the example problem before we look into the model. We have modeled an imaginary hotel project with several suites that are very similar. Each wall As you see here, each wall of the room is represented by room number and geographical location of the wall. So for example, this wall right here can be called as north wall at room 1, north wall at room 2, etc. Similarly, east wall at room 1, east wall at room 2, etc. So we have three types of work to be finished in this each rooms. So one is the finishing job, two is electrical, and the three is plumbing. As you can see, the plumbing job is not there at every wall, but electrical is also not there at every wall, whereas the finishing job is there at every wall. So in a logical order, the plumber should go first, the electrical, and then the finisher. So that's the logical order they should follow in the mod. I would like to close the PowerPoint presentation. Before that, I would like to thank all of you for listening to my presentation. After the presentation is over, you can send your feedback and suggestions to kiranpattur@gmail.com. Thank you. Welcome to the model. Here is the first view of how the model looks with 4 rooms as explained in the PowerPoint presentation, and each room having workstation at their respective wall. And each wall is represented by room number and the geographical side of the wall. Like here, this is called north wall at room 1. Similarly, if we click on any of the other walls, this is south wall at room 2. That's how it is represented, and these rooms are free to move in space anywhere. So these are not bounded to the architectural plan as is they should be. But since this is a data-driven model, we are not more concerned about how it looks and where it is positioned. As we can see, there are 3 persons placed here. Let's switch to 3D view so that they are better visible. So here there are 3 people who will be performing the work that we needed: plumbing work, electrical, and finishing. So we have color coded them with the matching colors so that each work package represented should be done by the same person in the same color. Let's switch back to 2D view. So the model pretty much does everything on its own once we give the data. We can choose on when to start the model, what time, when, and we can choose on when to stop. Like right now I have chosen 37 days. I'll tell you the reason for that later. We wanted the model to be intelligent enough to form its own teams, because in construction practice there is no standard team size. Supposing there are 4 finishers in one team, there can be 3 finishers in one team. And in this project we assume that the framing phase is all completed. It's the roughing phase where the electrician has to come in and do his work, and plumber has to come in and do his work, and then finisher comes after all of them to close the wall with sheetrock. So to accommodate this changes in team sizes, we have given the supervisor a facility where he can just give the number of people he has available here. So it says the electricians, finishers, and plumbers. In electricians, how many electricians does he have, and how many can be there in the maximum team size, and how many should be there in the minimum team size. Similarly for finishers and plumbers. This is done purposefully so that we don't have to feed in the number of teams always and collect, which becomes more problematic for the supervisor. So the model is intelligent enough to form its own teams once we give the number. We can change the number here very easily. 4 or 2 or any of these can be done. Right now I would like to leave the number there as is. So but overall it gives the flexibility for the modeler or for the modeler and the supervisor or the project manager to change numbers and play with the model. Similarly, here is a 3D view of how the rooms looks like, and since in 3D view it is better visible, I would like to hit the run button and see what happens. Once we hit the run button, immediately, since we started the work at 8 a.m. in the morning on March 3rd, we can see that all people go to work their respective work zones, like as shown here. The finisher with a team of 3, this one person represents 3 people here, and this one per electrician represents 2 people here. This electrician is single, this plumber is 2 people in the team. So they go to the respective work zones and they start working on it. Similarly, there are more teams available, so they start into the next room available, so that they go on a priority. If you see in room 3 and 4, there is no one working. That means after finishing their job here, they go to the room 3 and 4. So if we add a 5th room, it will be same. And we see that people are moving from one to the other. Once the electrician finished in room 1, the electricians come to the room 2. Similarly, now we can see the plumber moving in room 3, since there is a plumber already in room 2, I'm sorry. So this is, let's pause the model for a second and see how. So at this point we can see how many people are working and what time. Here it shows the time clearly. March 4th, that's the second day. So that's on visual animation, and animation can be done much more detailed way, like the colors can be changed. There are a lot more things we can do in the animation, but this project doesn't focus on the more on visuals, it focuses more on data. So let's dive into the data. Let me stop the model for a while. We have given work performance data for each work package. So depending on that, they perform work on each wall. Supposing for the finish, we can see here we have used a random triangular distribution, and we said it takes 18 hours to 24 hours, the pessimistic and optimistic timings, and 20 hours is the most likely time the work can be finished. Similarly, we have also included the team efficiency factor, which is if there are 3 members in the team, their performance is different compared to the 4 members in the team. And so that's what we have included, and we have done a separate data table for that. Let me walk you through into that table. So we have team efficiency tables here for electrician, for plumber, and for finisher, these tables. Let's go back to the facility view. Now similarly for electric work, it takes so and so time in pessimistic, optimistic, and most likely time, with including the team efficiencies. So these are the factors considered for work performance in the model. Supposing this wall is larger in quantity than this wall, so this wall takes more time than the east wall or the west wall. So typically south and north walls take more time than east and west walls, and that is accounted into the area here for the finishers. So it calculates the area square footage, which we have already given in the data table in schedule, which shows the north wall in room 1 is 120 square feet, the east wall in room 1 is 80 square feet, and so on similarly. So the model runs through that table and calculates the area surface area, and performs the work. Have electrician, finisher, plumber, 3 teams, and each of them have their respective work to be finished, which we can see here when we click on that. Let's switch to the data table where we can see all the data we have fed it into the model. So we said we have electrician, finisher, and plumber. These are the teams. We can add more team members if it is required. Types of work depends on the types of work that are done for that particular week. In the orders table, we can see this is the detailed list of all the tasks to be finished from room 1, all 4 walls finished, room 1 2 electrical walls, and room 1 plumbing. So all 7 tasks are combined, and we have given a particular deadline for each of them to be completed. These deadlines or the due date is derived from Microsoft project after we put in the same information that is we are putting into this model, but those were more deterministic. But however, this due date acts as a good startup for us to see how we will be able to finish, and this status here shows whether we will be on time or before time. So we said we can see here the orders table due date is the upper bound, so anything within the bounds is set as on time, and anything above the upper bound is shown as late. So it shows how many tasks we go on time, how many tasks we do it late. We have also incorporated schedules, the standard week schedule, which is a standard day from Monday to Friday, and day pattern in a standard day they have a work from 8 a.m. to 5 p.m. with 1 hour lunch break. These things can be changed as needed. If there are any holidays, public holidays and all, they can be fed into the model, so it becomes a real-time situation. Let's go back to the table, run the model. So let's run the model and see how the performance is. So now we have already seen how the animation looks like one after the other. The workers go from one wall to the other. So now let's fast forward this so that we can see the data table. Now we can see all the statuses that came on time, whatever is late, and some of them are on time and some of them are no value. No value, which means we have given only 37 days and 9th of April as deadline for this simulation running, the period of running. This is because the Microsoft project gave the last deadline due date was 9th of April. That's why we said we will run up to that 3 or 4 weeks and we see what happens. So this is a 5-week schedule approximately, where we can see that most of the work is late. This will definitely help the project manager to decide if they have less workers, if they have to add more people, or if they have to do any other thing. But there are more features that the project manager can use. Let's go into the planning tab. This is one of the most, since we have been changing model, it asks me to reset it. So I will reset, stop the model, and here we have the entity workflow, we have the resource plan, we have logs, tables, which are all different ways of understanding the problem. So let's go to entity flow and do the create plan. See, it says to display Gantt chart, click create plan. So now, boom, it goes very fast. When just one click I can get all the Gantt chart here, and it shows me which worker is working at what time and where is he. So this gap between is the Saturday and Sunday, the weekend. So people, we remember in our work schedule is a standard Monday to Friday. So Saturday and Sunday they're not working. That's how it is showing here. And it also shows the constraints also. When there is a plus sign here, when you click on that, it shows what was it constrained by. So this particular task was constrained by electrician. It says room 2 east wall electric work was constrained by electrician for 1 day 2 minutes, or approximately 1 day, because the electrician was busy and in the other room. Similarly, electrician 1 and 2 were occupied in the other room, so there was no electrician here. That's how it suffered. So it was wait. Similarly, we can see that this particular task is constrained by plumber. Similarly, this particular task is constrained by finisher. Go ahead and look into the resource plan. Resource plan is another useful tool for any project manager to check how. See, it shows us right away the constraints, entities, room 3, room 4, room 2, east wall electrical. You remember this. Remember, we have talked about this before. So all these from another perspective, from a different perspective, and it shows we have two electrician teams and where they are at what time and what they were doing in the project. So at any given point we can see the finisher is occupied for the longest time and it has constraints on the finisher. So there are two teams of finishers. Similarly with the plumber. So the plumber is less constrained compared to the finisher or electrician. So we may not need to increase the number of plumbers. So that's the more detailed input we get from the resource plan. So let's minimize and go back to the facility view, change few numbers here. Let's say we want to double the electricians. Also we want to double the finishers because we were constrained by finishers a lot, and we will say we need only 5 guys here. So let's say now we reset the model, but remember we had, now when we reset, all the finish dates and everything goes back. So if you want to save them, we should have done it before. But however, we know there were more lates and very few on time. So now let's see how the model turns. Now let's fast forward without waiting for a long time. Now it quickly gives us, and now you see there are more on-time works and very less late works comparatively to the before, and we can see which work is getting late and by how much. So that's another decision project managers can make if they have to fast track, and how much money do they lose for getting it on schedule, or is it better to leave it go late. Let's go to the planning task and see how it is on this time. Entity work optional, we will reset, we will stop the model and create plan. Let's go to the resource plan and see. Now we can see that finisher constraints is less compared to the previous model we have seen, previous number of persons we have seen. And that's how we can play a little bit on the numbers and see how many people we need for performing the work on time. But however, there is another important and interesting feature of this software, which is analyzing the risk. So now when we go here, there is another tab called Analyze Risk. So when we can have as many as 10 replications or 20 replications, or how many ever we wanted when we analyze risk. So let's see what happens when we click on Analyze. Boom. The model quickly gave me the possibilities or probability of these tasks reaching on time. I have set a confidence level of 90%. So anything closer to 90%, which the model considers this to be 90%, is shown in white. Anything in danger zone is all shown in red, and anything in yellow is very close to achievement, but it is not. So this is a very good sign to see how confident we are in achieving our targets. And we can change the numbers quickly and see how the model uh, changes these things. So we can either reset and go back to the model, and we can change the number here, maybe change it to 15 people, and go back to the planning stage and create plan and analyze risk. Well, it did make a little difference, but not too much. The number of yellow zones have reduced, and I believe one or two red zones have also reduced, and the percentages have increased. So similarly, we can control we can perform the performance classification we need for this project. Let's say we can do this. So that means anything in that zone is red, anything in this zone is yellow. That's how they count. And let's say anything we want to increase, that everything else becomes, so that's the confidence level we can control here. So depends on how confident we want our model to be. But I think this is a pretty good start for any research to proceed further and incorporate this concept into the real projects. The way we should be doing it is, when we start the model, we start with few standards on how much time the work performance takes, and what will be the work efficiency, all this. So in the first week, we start with the standard data, and we collect data throughout the week. When we collect data throughout the week and we feed the model with accurate data at the end of first week, that means we are going to have pretty accurate forecasts for future weeks. So if we continue to iterate this process again and again every week, that means by the end of second or third week, we will have pretty accurate measurements, forecasting system for the look ahead schedule. Supposing we have considered this project to be starting at 3rd of March. Let's say we collected data throughout from 3rd to 7th of March, the performance data, how quickly the electrician is able to perform, how quickly the finisher is able to perform, how quickly the plumber is able to perform, the plumber with two members in the team, the plumber with one member in the team, and similarly for finisher and electrician, the different team sizes. So when we put the exact data into the model spits out the accurate results very quickly at us, and if there are the project manager can take quick decisions if he needs to add more people or he needs to reduce people. Is he overspending on that? And I believe this introducing simulation modeling into look ahead scheduling is one of the best ways to control master schedule in the project. And also, this software has so many other features like handling of materials, handling of financials, all this, which I am not touching at this point, but this has a lot of future. Thank you very much for patiently listening to this video. Please feel free to contact me on the email provided in the PowerPoint presentation if you have any feedback, suggestions, or questions. I'll be more than happy to answer all your questions. Thank you.